Welcome to 5.6, angle, side, angle, and angle, angle, side. What's important that we show here is that the side of angle, side, angle is in between the two angles. Make sure that that's where you have it. And then when you have angle, angle, side, the side has to be attached to one of the angles. If it's in between, then it's angle, side, angle. So make sure it's in the correct order as well. All right, let's move on. Here we go. There's the triangle congruence theorems. We have side, angle, side, 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 hypotenuse, leg, angle, side, angle, and angle, angle, side. Those are all your possibilities of what you have, and it has to be in the exact order. All right, number one, decide whether enough information is given to prove that the triangles are congruent. All right, so notice our order, A, B, C, double angle, single, hash mark to C, and then QRS, double to single, to the vertex. All right, so that's in the right order. And what do we have here? We have angle, angle, side. Angle, angle, side. All right, angle, angle, side. So it's correct, so we would say yes, that would be angle, angle, side. Okay, number three, again, check your order, X, Y, Z, double to single to the angle. J, K, L. J to K is double over the single to the angle. All right, so everything's in the right order. And now, what do we have here? We have side, side, angle, which we can't have side, side, angle. There's no such thing as side, side, angle. Hypotenuse leg is side, side, angle, but that's only if you have a right triangle, and we do not have a right triangle here. So there is not enough information there. All right. Decide whether you can use the given information to prove that the two triangles are congruent. All right. So let's just draw two generic triangles and label them A, B, C, and make sure we label them in the right order, D, E, F. We don't know if they're obtuse or right. Let's just use these to figure it out. Angle A and angle D are congruent. Okay. Angle C and angle F. All right. And AC is congruent to DF. Okay, so I'd say yes by the angle, side, angle formula. Okay, now let's do it again. Let's do two triangles, A, B, C, and D, E, F. And B, angle B is congruent to angle E. Angle C is congruent to angle F. And AC is congruent to DE. AC is congruent to DE. All right, those are in different places, okay? Okay, so since they're in different positions, you can't say angle, angle, side. We have angle, angle, side here, but it's going the opposite direction to get there. We're going from a double angle here to a single angle to the side. Here you're going from a single angle to the double angle to the side. So no, there's not enough information to prove what we need. Okay, so what did we do wrong here? We have angle, angle, side. If we go this direction, double, single, side, double, single, side. Okay, so that's working. But it says by the angle, angle, side. And so far, we're saying that's true. But now we look at the order. So JLK. So JLK. So we go J to L to K. So let's draw that. So J to L, then to K. All right. And now we're going to do F, H, G. So F to H to G. Notice J doesn't have an angle, and we're starting there. F, we're starting at the single angle. So we're starting at different places. So that's what they did wrong. They ordered these incorrectly. So let me erase all of this, and let's start that part over. So what is wrong is this information here. So let's do it right here. Let's start at J. So triangle J. We're going to go across the single hash mark to K, and then to L to the double angle hashes there, okay? So we're going to start at G then, because that doesn't have an angle there, angle G. And we're going to cross the single hash mark to F and then end up at the double angle hash marks. So this should be the correct order that you place everything. All right, 13. Prove the triangles are congruent. All right, let's do this. So what's been given? So all of this goes right here. M is a midpoint. So if M is the midpoint of N to L, that means MN is congruent to LM. Definition of midpoint. Okay. And then we see that NL is perpendicular to NQ. Okay. And that's marked. NL is congruent to N, or not congruent, as perpendicular to NQ. That's marked as a right angle. NL is perpendicular to MP. That's marked as a right angle. And QM is parallel to PM. All right, so we should mark that. Let's put, let's see, QM. Oh, it is marked. It is marked right there. Those two are parallel. Okay, so if those two lines are parallel, let me draw this in yellow. So we have that line right there. It's parallel to that line. And it's cut by this transversal, which makes corresponding angles congruent. Okay, so that has, we can say, angle QMN is congruent to angle PLM. And that would be corresponding angles theorem. And we can also say angle QNM is congruent to angle PML. All right angles are congruent. Okay, so technically speaking, we have triangle. We have our proof statement here. Triangle NQM is congruent to triangle MPL because of angle, side, angle. So we have the angle, we have the side, and we have the angle. All right, so let's start with another proof here. Again, we have our givens. And this piece goes right here. VW, let's see, what are we trying to prove here? XWV. All right, so I'm going to draw this out here. We're going to draw these separately. All right. So there's X, W, and V. And Z, W, U. Okay, so they're going this way on this one. Z, W, and U. All right, so W is congruent to itself. That's reflexive. We can think about that. So let's make sure these are marked on our two new drawings here. So we have VW is congruent to UW. Let's mark that. VW is congruent to UW. All right, and angle X is congruent to angle Z. And then we also know that angle W is congruent to itself. Let's just go ahead and say that. Angle W is congruent to angle W, reflexive. And we can mark it. So now we have angle, angle, side. Angle, angle, side. So we can say our proof statement. So triangle XWV is congruent to triangle ZWU. Angle, angle, side. That only took 3 steps. All right, what additional information do you need to prove that JKL? All right, so let's draw this out here. So JKL is congruent to MNL. So MNL. Okay, so MNL. There you go. So KL and LN are congruent. And we're trying to do it by angle side angle. Well, to do angle side angle, first of all, look up here. We have angle L is congruent to itself. So we can mark that already. So we have angle side, and we need the other angle. And remember, the side has to be in between them. So that means angle K here, and angle side, angle N. Angle K and angle N have to be congruent. Angle K and angle N. LKJ and LNM. So this answer would be D. That's what we would need to finish the angle side angle. Find the coordinates of the midpoint of the line segment. Okay, so midpoint again is x plus x over 2 and y plus y over 2. So negative 2 plus 4 over 2 and 3 plus negative 1 over 2. And we get 2 over 2 or 1 and 2 over 2 or 1. So 1, 1 would be the midpoint. So just to show you, let's go ahead and graph this and see where we get. Negative 2, 3 is right here. 4, negative 1 is right there. And the midpoint is at 1, 1. And if you connect them, you can see that that is pretty much the midpoint. Okay, decide whether enough information is given to prove that the triangles are congruent. Okay, so BAD and DCB. So BAD and DCB. And say, yes, there is, because of side, side, side. BD is congruent to itself. Reflexive property. So you have all three sides congruent to the other three sides. And then number 40, JKM and LMK. So we have one side, and then we have the reflexive side. Okay, so we say, well, I'm going to say yes because of side, angle, side. And you say, well, I see the two sides. What about the angle? Well, first of all, the other side is KM. Let's make a little space here. KM is congruent to MK. That's reflexive. Okay. And then you have this angle right here, alternate interior angles with this one, because these two lines are parallel. So you have two parallel lines cut by that transversal. So this angle right here and this angle here, they're interior and alternate. So you say angle JKM is congruent to angle LMK, alternate interior angles. There. And then therefore you have side angle side. Good job.